Hi there, this is Sisir Koppaka from Blue Inside Digital, and I'm here to talk about the power of Scala with large language models. So, we all know Scala is a very capable language. Firstly, it's a functional language with an OOPS background, which makes it both practical as well as very technically correct. It has great support for compositionality, which allows us to represent a larger variety of real world programs in a much more safer manner. And it has got great support for types, and type safety is important in Scala, because of which there is a very improved developer experience. So we work at Blue Insight for a lot of clients on AI and Scala based projects, and this talk came out of an intersection of both of those interests. So in this talk we are going to look at large language models, or LLMs as they're usually called. What are they? Why do they exist? We're also going to look at a practical use case of these LLMs and look at the differential impact that LLMs can have in such a scenario. We're also going to specifically look at how do we build with LLMs. So how do we extract structured data with LLMs? How do we summarize with LLMs? How do we do sentiment analysis? And how do we generally form better queries and prompts for LLMs? So by way of stacking, map reducing, or by using the interpreter pattern, which we will discuss at the end. That's an interesting use case where we will be using the free monad to come up with something useful using LLMs. So one important thing to realize throughout this talk is that principles of functional programming are always useful and adaptable, even given the advent of LLMs. There is some amount of adaptation that is required because obviously there is some translation that needs to happen between different areas. But nevertheless, it's good to see that functional programming stands strong, even though there are large changes happening in the industry. So this is what an LLM looks like. So this is actually ChatGPT, which is a product built using the LLM GPT-4, so which is a model. So you have a prompt, which is a question, and then the model answers that question with the response, which could be text, vision, it could be images, it could be anything. And you iterate on this conversation essentially. So prompts are also code, and that's important to realize here. Prompts could be text, vision, but in this talk, we're just going to consider text prompts. So prompt engineering is an important part of working with LLMs. So how does an LLM actually work? So you take a prompt, which is a question or a series of an instruction or something that you want out of the LLM. You encode it as a prompt, and this is broken down into tokens, which are sequences of characters, and then fed to an encoder, which creates an internal representation that is in turn given to a predictor, which generates the predicted token. So this simple model over a large enough corpus creates remarkable results, and that's how LLMs function. So LLMs can be really good at a lot of tasks. Some of them are listed here. We won't go into them in detail, but we will touch many of them, like summarization, question answering, and sentiment analysis in this talk. So there are some limitations of LLMs that we need to keep in mind, and Jan LeCun, who's a famous AI guru, believes that there is some important points that you need to keep in mind regarding how LLMs are limited. So if we consider the probability E to be the probability that any produced token takes us outside the set of correct answers, outside the tree of correct answers, which is marked in green, into the blue, then the probability that the answer of any length n is correct is 1 minus e power n. So this diminishes exponentially. So because of this divergence, we cannot really fix LLMs. Because the longer the answer is, the more unlikely it is to be correct, and it's more likely to go wrong. So nevertheless, LLMs are very powerful enough today to be dangerous and very useful, and that's what keeps us engaged and motivated here. So let's look at a very simple example. This is a customer touchpoint map, essentially showing how a customer is initiating contact and creating a ticket for a pain point that they experience with the product. So at every touch point, you have an option, whether it's creation of a ticket or a categorization of a ticket into different categories, which will help the agent resolve the ticket better. The resolution of the ticket, which is a massive gain point, and the time that it takes to resolve the ticket needs to be as minimal as possible without escalations. So there are a lot of these goals that you have, sub goals that you have in the touchpoint map of the customer. And we're going to look at how LLMs can really help with their technology combined with Scala in how we can solve for this better, how we can create a better gain point out of a pain point in this scenario. So for example, we're considering a ticketing system which has a very simple form of a ticket. So the ticket consists of a message, which is, in this case, it says, I purchased this mixer from KitchenAid a few weeks ago and I found it ridiculously useful to juice up my day. It's just a positive feedback message. And there's an author label. So this is all the ticket is. We are going to use LLMs to reduce the mean time to respond in this entire process for ticket management. So we're going to do a bunch of tasks there, extracting product related data, improving the ticket summarization, providing for ticket sentiments, generating tag clouds out of tickets, all of this automatically without any human intervention. And we're also going to apply functional programming, firstly to scale across multiple tickets to do map reduce operations, and secondly to use the interpreter pattern with the free monad to provide better ways of forming queries and storing them so that we can target multiple backends of LLMs. So first, in this section on prompt engineering, we are going to look at some practical use cases. The use case that is described, we're going to read a ticket and write a ticket. So in this case, we have a cask post request, which is going to just read a ticket from the request, deserialize it into using upickle into our ticket store.ticket, and we're going to write that out using upickle as well. So we're going to read and write a ticket out. This works as expected. There's nothing sophisticated about this. So our goal is, as we discussed, to create an enriched ticket from a ticket. An enriched ticket contains the ticket but also contains the other fields such as product, subject, what is the summary of the ticket so that it's useful for other people who are working in the process flow, the sentiment of the ticket, is it positive, negative, neutral, tags, any tags that uniquely identify this ticket so that we can find related tickets in the past and see if there are some reoccurring scenarios that we are noticing in the data. So this is how a simple LLM query looks like. So for the first case, we are going to just extract the product name as structured data from the LLM. So by structured data, we mean two things. One could be a JSON. We have a prompt which extracts it as a JSON. In that case, we just ask the LLM to reply in JSON with the field name and so on. Or we can just ask for a textual prompt, which is what we'll go ahead in the example with. So LLMs understand what is structured data, but we have to be very specific. In this case, we are saying that extract the name of the product being talked about, be as specific as possible, include the brand name and the product name, reply with just the name as text. So we have to be so specific for the LLM to be giving us back the response of the product, the response as the product that it's identifying from the ticket message. So at the ending of this query, we are also asking, we're calling a helper method called ticketAI.getOutcome, which gets the outcome of the conversation with the LLM using the prompt that is in text in this particular request. So you can see the response back from the LLM. It comes out as, it identifies the product as very clearly KitchenAid mixer. So it's very good at identifying this kind of things, and you can scale this to a lot of tasks where structured data is required. So you don't have to get bottlenecked and build out a whole set of UI and flows to handle how do we extract manually. So LLMs can do that for you automatically. The next step is to summarize the ticket into a subject field where we are asking the LLM, hey, summarize this review below in a heading. Heading should be a short sentence of less than 15 words. Be creative, but be as close to the text as possible. The idea is that we're going to use this for really creating a easier way to translate the ticket, which might be very long, for all of our agents to understand. And this is also quite easy. You can see the subject that it's extracted for this longer message. It says perfect for beginner bakers looking for a versatile and user-friendly artisan mixer. So it's a positive thing, and what is it positive about is also very clear from the subject. So this is capability of LLMs to change the density of entities in the text is very important in prompt engineering. So you can accomplish very creative goals by iterating on this method repeatedly and synthesize a new prompt out of an older prompt. So this is called the chain of densities technique. In this example, we are going to look at the sentiment of the ticket. So determine the sentiment of the product review below. Be specific and answer with positive, negative, or neutral. One word response only. So you have to be so specific when you're talking to the LLM. And the idea is that we're going to use this for surfacing the negative feedback first, so that the agents can respond to that ahead of the feedback from the positive ticket, so that any negative backlash can be controlled. So you can see that this also, it works pretty fine as advertised. The sentiment is marked as positive and the LLM is able to deliver on what it promises. So we can be more open-ended about it. Sentiments are more like constrained. You're saying that like choose between these three options, but positive, negative, and neutral. But in the tags, we are going to look at more open-ended, like descriptive tags for the ticket. We are going to determine up to 3 tags. And we are telling the LLM to be very specific and descriptive and answer with 3 comma-separated one-word tags only. If in case there's more than one word, hyphenate it and make it a single word. So the LLM responds with beginner-friendly, artisan, and attachments as the 3 tags that it's chosen for this particular ticket. So this eliminates a lot of complex operations where this was a very creative process where humans would be involved in a very significant basis. So together with categorization of the sentiment tracking, we can actually solve the ticket categorization problem completely in an automated fashion. We can obviously apply flat map and other methods in Scala that we are familiar with to do map reduce with tags to create a tag cloud. So this is for 2 tickets, we are looking at the tags, and then we could obviously form a tag cloud out of this and look at which tags are contributing to the MTTR being slow in the system. So that would help us identify where we could make the maximum improvements in our customer touchpoint map. So here's a quick look inside the ticket.ai.getOutcome function. So this is the helper method that we've been using to get the outcome of the response from the LLM. So we are forming the query with the LLM by using this particular data structure provided by the library called message spec, which consists of a role and some content textual content. So the role can be either a system role. It can be a system role, which means that somebody is instructing the entire system to perform in a certain way. Like you are a helpful assistant is an example that's here. A user role where it's a prompt that the user is generating or has generated in the past. So it's a document of that particular conversation. Or if you expand the use case, it could also be, you could also include the assistant role, which is what did the LLM respond? Even that could be part of this stack of queries, the history of the chat. It's basically like you're chatting and you're recording the history of the chat, and then there is a new prompt that is being added by the user at the end to which the LLM responds. So that final prompt is located here in this image as prompt. And in this case, it says you're a helpful assistant. That's a system message. And there is a user message which says who won the World Series in 2020. And then the assistant responds by saying the LA Dodgers won the World Series in 2020. So the final prompt is something going to be similar to what we are going to ask earlier, and we are teaching the LLM that, hey, look at this query and answer. This is how I want you to perform. I want you to answer a question when it comes like this in this manner. It could be about some other topic, but that's what I want. So this is my overall prompt. This entire thing is my prompt. So when I looked at this, we thought about using we recognized it first of all as an interpreter pattern, and then we could use the free monad from cats to kind of implement this in a better way so that we can target different LLMs backends, for example, not just GPT-4, but also like Llama 2 and other LLMs. So it's really helpful to use the free monad here in this use case. And that's why functional programming is always useful. It's never you should never give up on it, because even if LLMs have come in, it's a brand new technology, but still there's a lot of use cases here that relate to functional programming. So here we construct an ADT representing our grammar, and then we free the ADT with the free monad in ticket free. So ticket free is like a free implementation. And in this, we have a nice for comprehension which translates the previous stack of queries that we saw. As system says you're a helpful assistant, user says who won the World Series in 2020, assistant says the LA Dodgers won the World Series in 2020. The user says, and this is the actual prompt, who won the most recent Cricket World Cup. And then we execute the chat, capture the result, and then let the result out, get the outcome for that conversation. And this works as designed, and we get the answer back as from the LLM as the most recent Cricket World Cup was held in 2019 and was won by England. So that's very fantastic. So LLMs are very useful, and Scala is even more useful, and combining both of them can lead to very interesting places. The code for this is available online, and we thank the library authors behind OpenAI Scala client, Cats Free, Cask, and UJSON. Thank you so much.